Hello, Year 10. Today we're going to be looking at area of basic shapes, including circles and sectors. But before we do that, let's revise some things from earlier on in the topic. So question 1 says, find the exact value of x and hence the perimeter of the shape shown. Now to find the perimeter, we want to know all of the sides around the outside of the shape so that we can add them all together. So we have the 7 and the 14 and the 20 going around the outside, but we're missing this side here, which is called x. In order to find it, I'm going to need to use this first right angle triangle to find the missing side here, which is the hypotenuse. And then I will use the second right angle triangle to find the x. Okay, so first lot of Pythagoras' theorem, we're finding the hypotenuse, which has the formula h equals square root of a squared plus b squared. The two sides that I am using are the 7 and the 14. Putting that into your calculator, we can do that for the underneath part of the surd, but we do want an exact value for our final answer. So let's just put in 7 squared plus 14 squared, which means it's the square root of 245. Okay, so this side here is the square root of 245. Now we are going to find the shorter side in the second right angle triangle. The formula for that is a equals the square root of h squared minus b squared. A just stands for the shorter side, but our label is an x. We're going to say x equals. The hypotenuse is 20, so 20 squared minus the square root of 245 squared. Okay, now again we want this exact, so let's just put in the part underneath the square root sign. So 20 squared minus bracket square root of 245 squared. Now just remember that the squared and the square root will undo each other, but the calculator will take care of that, and we get 155. Square root of 155. If I could simplify that surd further, I would, but that's as much as we can do. So that will be the exact value of x measured in centimeters. We now need to find the perimeter of the shape. So perimeter is going to be adding up all the outside side lengths, 7 plus 14 plus 20 plus the square root of 155. Now the numbers at the front we can add together. 7 plus 14 plus 20 makes 41 plus the square root of 155 centimeters. Okay, great. Moving on to question 2. We want to simplify some surds that involve fractions, and that means I need to find a common denominator. So timesing 4 with 5, we get a denominator of 20. Timesing diagonally, 5 times root 2 is 5 root 2. Plus, now the other diagonal, 4 times root 2 is 4 root 2. On the top we have like surds, so 5 root 2 plus 4 root 2 makes 9 root 2 over 20. And that's all I can do. Okay, so now looking at area, we want to be able to convert between area measurements, which would be things like kilometre squared, metre squared, centimetre squared, and millimetre squared. Now remember the 10, 100, 1,000 from before, but when it's area, now these are all squared up here as well. So remember, if you're going from bigger units to smaller units, you're timesing, and from smaller units to bigger units, you're dividing. Also, we have a special unit for area, which is the hectare. A hectare is a unit of measurement of area that we like to use for measuring land. So what you need to know is that 10,000 meters squared are in a hectare. So if you have hectares, you times by 10,000 to get to meters squared, or meters squared divide by 10,000 to get to hectares. So HA is our symbol for hectares. Okay, formulas that you should already know. We have the square, which is A equals L squared. A rectangle, A equals BH. If you do things like LW, there are other formulas that mean the same thing, that's okay. The area of a triangle is half base times height. The area of a trapezium is H over 2 bracket A plus B. A parallelogram is A equals BH, which is the same as the rectangle, but the base and the height need to be at right angles to each other. You would never use the sloping side as the height of that parallelogram. A circle is pi r squared. A sector, we want to find what fraction of the circle we have, which is the angle over 360, and then we times it by the pi r squared, which is our area formula for a circle. A rhombus and a kite both have the same formula, which is half xy. The x and y represent the diagonals, so it's not a side length, it's the diagonals going from one corner to the directly opposite corner. That's the x and the y. Okay, so question time. Question number 1. Convert these areas to the units shown in the brackets. So first of all, we want to go 4.5 centimetres squared, and we want to change that to millimetres squared. So if you look at our conversion chart, centimetres squared is here, and we want to go to millimetres squared, so following the arrow means we want to times by 10 squared. So in here we're going to go times 10 squared. On your calculator you just type that in. So we have 4.5 times 10 squared, and that makes 450 millimetres squared. Part B, we want to go from centimetres squared to kilometres squared. So back up to the chart again. Centimetres squared are here, and we want to go 2 jumps over to kilometres squared. So we need to divide by 100 squared and then 1,000 squared. Divide 100 squared, divide 1,000 squared. And we get 300,000 divide 100 squared, divide 1,000 squared, which makes a very, very small number, 0.00003 kilometres squared. Okay, next we're moving on to our area of shapes. So the important thing is that you know what each of your shapes look like. This first shape is a trapezium. Once you identify the shape, then you write down the correct formula. A for area equals H over 2 bracket A plus B. So if you've not already done so, please make sure you memorize the formulas that were in the chart before. The A and the B are the two parallel sides. It doesn't matter which one is which. So I'm calling A the 10 and B the 25. H is the height, the perpendicular height, so you need the right angles in there, between those two parallel sides, which means the height is 15. Subbing that in, we get 15 over 2 bracket, A is 10 plus B, which is 25. Putting that in your calculator, you will get 262.5 centimetres squared. You must remember to include your units. Great, over the page. Next shape is a circle. The formula for a circle is A equals pi r squared. So we have to use the radius, but the 25 here is a diameter. The radius will be half of 25, which is 12.5. Subbing that into the formula, we get pi times 12.5 squared. Putting that in your calculator, pi times 12.5 squared is 490.87. And that will be centimetres squared. Part C is a triangle. The dotted lines, we're not trying to find the area of that. That is just there to show us the perpendicular height of the triangle. We're trying to find the area of this triangle here. So the formula for any triangle is A equals half base times height, where the base and the height are perpendicular to each other. So the base is 7.4, and the height, even though it's not part of my triangle, is the 2.3, because it's perpendicular to the base. Timesing that together, we get half times 7.4 times 2.3 is 8.51 meters squared. Part D is a sector. The formula for a sector is theta over 360 times pi r squared. The theta is the angle inside the sector, which is 310 degrees, and the radius is going to be the 2 centimeters there. Subbing those in, we get 310 over 360 times pi times 2 squared. In the calculator, you will get 10.82 centimeters squared. Part E, we're trying to find the area of the part that has the solid line. So again, not the dotted part. So that kind of like a square with, well, it's really a rectangle with a quarter of a circle cut out of it. So we're going to combine two formulas here. I'm going to find the area of the big rectangle going around the outside, which would be this one I'm doing here in green. So I want the area of that rectangle, which would be base times height. Then I'm going to subtract off this quadrant, this quarter of a circle here that I don't want. Now, because it's a quarter of a circle, I could use my sector formula, but it is faster if you just go, I have a quarter of pi r squared. If you use the quadrant formula, it means you'd have your theta over 360 times pi r squared, and your theta would be 90 degrees. You get the same result. So subbing into the formula, the base times the height, so the base of my big rectangle, I have this 4 here, and then because of the markings, it'd be 4 and 4 across the top here, so it'd be 8, not centimeters, meters in total for the base of that rectangle. So 8 times 4 is the area of the rectangle. Then minus a quarter times pi times the radius of the circle would be this side here, which is also 4, so 4 squared. Typing that in the calculator, we get 19.43, and that will be meters squared. Question 3. Find the value of the unknown pronumeral correct 2 decimal places. So we have a trapezium again, but what's different about this question is that we're told the area is 51.3, and we're trying to find this missing side here, which they're calling y. So we will need to use the trapezium formula, which is A equals h over 2 bracket a plus b. Then the height is going to be the 3. The a and the b will be the 2 parallel ones, which I will call the a the y and the b the 7. It doesn't matter if you do it the other way around. Subbing that into the formula, the area is 51.3 equals, the height is 3 over 2 bracket, a is y and b is 7, close bracket. Okay, trying to get the y by itself, the first thing you would do is times this 2 over to the other side. So 51.3 times 2 is 102.6 equals 3 bracket y plus 7. The next thing I would do would be to divide by the 3 to get rid of that from the front of your bracket. So then you'd have y plus 7 equals 102.6 divided by 3 is 34.2. And finally, you subtract the 7 and you get y equals 27.2 meters. Just meters, because this is not an area. It is the length of the bottom side of that trapezium. Question 4. Find the exact area of the sector shown. The area of a sector is A equals theta over 360 times pi r squared. The theta needs to be the angle inside the sector, so it's trying to trick us here with the 100 on the wrong side here. 360 minus 100 tells me the angle inside should be 260 degrees. So I need 260 over 360 times pi times the radius, which is 2 squared. Now, if we need to leave this exact, it means I don't want to put the pi into the calculator, but I'll do the rest of it. 260 over 360, and then timesing that by 2 squared, so ignoring the pi, and I get 26 pi over 9 as my answer. That will be in meters squared because it's the area. Question 5. And this is a bit of a challenge question, this one. Find, correct to 2 decimal places, the percentage of the area of the largest circle that can be formed inside a square as shown. Okay, so if I want to know the percentage that this circle is of the square. To find a percentage, I would need to know the area of the circle, and I would divide that by the area of the square, and then to make it a percentage, you would times all of that by 100. The trouble is I don't have any dimensions on this shape at all. So I'm going to introduce some letters. Looking at my circle, from the center of the circle to the edge, which would be the radius, I'm going to call that x, which means the side length of my square would be 2x because it would be the same as the diameter, since the circle is touching the whole way around. So the formula for finding the area of a circle is pi r squared, which, for me, my radius is x, so it's going to be pi times x squared. The area of a square is a equals l squared, but the length of my square is 2x, so it's going to be 2x squared. And then that is going to be multiplied by 100 so that we can find a percentage. Expanding the brackets on the bottom, we have pi x squared on the top. Squaring the 2, we get 4, and the x squared times 100. Now, the good news is we've been a bit concerned because we've had letters in this and we want to get a number answer. But we have got an x squared on the top and an x squared on the bottom. They will now cancel out. So to find the answer, we can simply type in pi over 4, and then we times that by 100 to find out that it is 78.5 because we wanted 1 decimal place. So 78.5% of that square is the circle. Okay, that's the end of our examples. You can now do exercise 4G and also the progress quiz.